Right, so next video. This is the I've still got the oscillator board here because it's easier to connect to. I just haven't taken it down yet. What I'm looking at now is the counter output on the scope. I've got a DC offset and stuff on there, so it's why it's offset as it is on the scope. And let's drop the camera down a little bit so you can see a little bit better. There we go. Alright, so that's the counter output showing 100 kilohertz, which is what I'm injecting into TP2 on the oscillator board. So the 100 kilohertz being generated through the oscillator board, going through the oscillator control board and coming out of the counter output on the back of the oscillator control board. Well, to the socket on the back of the unit. Right. So at least I know that 100 kilohertz is passing right through the oscillator control to the output of the counter output. Right. And if I change ranges, it disappears because it's it's just not there. Right. 1 megahertz still shows up though. Interestingly, it's passing right through there. But yeah, so that circuit is working. That's something, right? So that's the first stage. Don't forget to subscribe and give us a thumbs up if you're following this along and trying to help me, well, trying to see how to do this, because I'm sure this video is going to help a lot of people with their own units, trying to figure out what's going on. So I believe I've eliminated this board here, which is the oscillator board, as an issue. The next one I'm going to look to now is the oscillator control board. This board isn't oscillating by itself. If I'm injecting a signal, if you look at my last video, part 8, which is dedicated purely to this board and diagnosing this board, right? Go back and look at that if you've got issues yourself. But this board isn't oscillating itself. But if I'm injecting that 100 kilohertz signal in this case into TP2, it's passing right through the board and coming back out. So the board itself is working. I've verified all these amplifiers are working. So go and look at the other video if you haven't watched that yet, if you're trying to follow along. Okay. And so the next one I'm going to do is the control board, which is what I'm just about starting on now. But I wanted to show that before I took all this down. Okay, so now I'm measuring the quadrature output on the back of the unit, which again is coming through this board, through the oscillator control board, out to the back, and there's a signal right there, amplified as expected, and that is measuring massive voltage. Actually, that's surprising. Hold on a second, I've got my probe pushed. Here I have. There we go. Have my probe set on times 1 instead of times 10. Just putting this back up again. Alright, so that's 6 volts. Okay, so yeah, that's all fine. So it's passing right through, at least the quadrature output was working, so I can verify that part of the oscillator control board is also working. So, so far so good. Okay, so the previous test is on 100 kilohertz. Now I've changed to 10 kilohertz. Because this goes to some slightly different frequency control, and it's got some relays and stuff which click in on the oscillator control board. And as you can see here, I've got 6 volts at 10 kilohertz coming out. I've got 10 kilohertz going in on the 10 kilohertz range. Right, we change ranges, it disappears. Okay, so now I'm going to do 1 kilohertz. I think I can do 1 kilohertz. No, I can't. I can do 10 kilohertz on this. I can't go that low on that thing. I'll have to think about this. How am I going to test 1 kilohertz? I'm going to have to hook up to my signal generator on the oscilloscope. I think. No, actually no, I'm going to use my Polaroid. Okay. I'm going to start my Polaroid, which is up there. I'll speed the camera back a bit. Okay, that's over there. It's Polaroid right there. So I'm booting it up. That can do up to 10 volts. It's 1 hertz to 1.3 megahertz, so I can use that. It's got variable output and stuff as well. I'll use that, inject that instead, and use that to do those lower frequencies. Turn that off. Let's plug this into here. I want AC output. Let's do 50 millivolts output. 50 millivolts. and that's currently at 10 kilohertz. So that's got a very fine variable. So I'm going to go 1 kilohertz on there. So that should produce an output. Here we go. So let's just bring this frequency down a bit so you can see it. And you can see it's actually overdriving. So let's just reduce this level a little bit. Let's do 10 millivolts. Probably a bit too low now. 20 millivolts. 30 millivolts. Got to find that point where it starts to work. Yeah, 40. Let's wind this up. Interesting. It's not doing the same thing now. Anyway, I don't know what range, like 1 kilohertz, 1 kilohertz. Right. I wonder why I did that overdriving. That's strange. Anyway, let's get this trigger set so you can see it. Big level up. So that's doing 4.5 volts output right now. Maybe it's my probe playing up, maybe. I don't know. I'm suspicious actually there could be an issue there. Let's go back to 50 millivolts. So yeah, that's all right there. Change ranges, disappears, and that is 1 kilohertz. So the quadrature output there is also working okay at that frequency. If I change ranges on here, it's all stepping okay, as it should. Right, that's working alright. So now let's do 100 hertz instead. Let's do variable 100 hertz. Still 50 millivolts input. Let's make it a bit bigger. Right, it's now doing 3 volts output on the quadrature. So, okay, is that slightly off? Maybe. Let's see if it changes for better or worse by changing frequency. No. Does it tell you how well tuned it is? Yeah, that's pretty good actually. It is peaking at 1 kilohertz. So 100 hertz. So yeah, and it's measuring 100 hertz on the scope. So it just seems that it's a bit of roll off on there on that frequency. So, right, let's go down to a lower frequency. Let's go 10 hertz and drop this down to 10 hertz. There you go, it's 10 hertz. Yep, that's pretty damn close, alright. So, trying to see where it peaks. Yeah, it's peaking about there, which is 10.2 hertz. Let's get some more on the screen so I can count properly. It says exactly 10 hertz on there, so yeah, it might be slightly off frequency there, but there's not much in it. So that shows to me that the switching is working correctly on those ranges. So that's all pretty good. I'm happy with that. Okay, so now I've got the oscillator control board set up in the riser card, and I'm going to do some voltage measurements on the frequency inputs, which are in this area here, which is U4, which is that IC right there. Yeah, I was checking for anything getting hot. Oh, that one gets hot, but I've already verified that one works. That one is getting warm. Yeah, U11 and U15 are getting slightly warm. Only slightly. But that one there gets hot, which is U14. But I've already verified that one actually works. So that's a little bit interesting. That's getting very hot. So I might replace that part, but I know it is working, so it could be a fault inside it. Anyway, I've already ordered some parts. So I just bought a whole bunch of parts whilst I was doing an order, so I do actually have a part to replace that with. Yeah. So back to this U4. Now this is the frequency inputs. So depending on which range you're set, so like 100 kHz to 1 MHz, it changes the inputs onto this IC here, and that controls the what? That controls the amplitude control circuit. So I'm still trying to diagnose why the oscillator is not running, and that loops through this board as well. So I need to figure out why. So I'm on 100 Hertz, set to 100 Hertz. Output's currently off, but it doesn't matter because I'm just doing frequency ranges. Doesn't actually matter. 1 volt range, that sort of stuff. So let's go pin 1. 3.6 volts. 3.6 volts on pin 2. Pin 3, 0 volts. Which are correct for the 100 Hertz range. Pin 1 and 2 are joined together. It's acting as a as an inverter in that stage. So this is a an AND gate. Okay, it's an AND gate configuration. So pin 1 and 2 are joined together. Right, it's just acting as an inverter. So that first stage is working and that input is correct. Now let's need to verify that the input is switching correctly. So that's on, off, on. So it's on the 100 Hertz, 1K Hertz and 1 megahertz, which is correct according to the chart on the circuit diagram. So that is correctly switching. Now I need to look at the next input, which I'm going to do as let's do pin 9, 10 and 8. 9, 10 the input, 8 is the output. So 9, 10, so that's going to be 1, 2, 3, 4, 5, 6, 7, that's what I thought, 8, 9, with the inputs first. So that's 9, which is high, that's on 100 Hertz. And on 1 kilohertz it's off, 10 Hertz it's on, 100 kilohertz it's off, 1 megahertz it's on, which is correct. And pin 10 is the fed from the pin 3 over here, which one I've already tested, so I know that works correctly. So I need to verify the signal's getting there though. So I see to see, yep, that's looking correct. And I need to check the output, which is pin 8, to make sure that's logically correct. So that should be summing those. So what should that be? On, well, 1 on. So if I go to 100 Hertz, let's do it on the base frequency. Let's work this out. So 100 Hertz, pin 9's on, pin 10. So I should just verify these. So 9 on, 10 off. So that should be off. Sorry, on, because it's inverting. Right. So that's off, so it should be on, so it should be off, correct, and off, on, should be on, yep, and on, off, should be on, correct. Right, so that second section is okay. Now I need to look up pins 11, 12 and 13. 12 and 13 are the inputs. So that's 14 pins, so that's 12, 13, so 12 and 13. So I'm back on 100 Hertz, and pin 12 is the same as the input I had on the first one. So it should be high, high, low, low, high. Yep, correct. And pin 13, let's go back to 100 Hertz. Pin 13 is from frequency range 4 input, which should be high, 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 low, high, 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 low. That's all good. That's correct. So now I should just check the output, which is pin 11. Alright, so that should be off, so that means that should be high, correct. That's off, so it should be high and high, correct. That's on, so one of them should be low, correct. That's high, so one of them should be low still, correct. And that should still be high, that's correct. So U4 is definitely okay. And the inputs are definitely okay. Right, so the next one, I've just turned the light on there to try and help the lighting. I just realised it's not particularly the best. So the next one I want to check is U5. Now this converts the BCD input, from which I just checked on this chip as well, into individual lines for switching purposes. This feeds switching transistors, which controls these relays, things like that. Okay, so I need to look at, I know the inputs will be there, so I'm just going to go straight to the output and make sure the outputs are switching. So I want pin 3, 4, 5, 6 and 7. I believe that's correct. No, those are output numbers. So I want pin 4, 5, 6, 7 and 9. Right, so pin 4, I'm going to measure directly on the pin, and in case there's an issue it will show up. Pin 4, that's currently low. That is supposed to be the 1 megahertz range. Nothing. Well, this is not 1 megahertz, which is interesting. So it looks like it is putting low and it's floating there, so it looks like. Okay, so these are not signals. So pin 5, 2, 3, 4, 5, that's set on there, 6, 7, 5. It was on 4, wasn't I? No, I was on the wrong pin. Okay, I think. Yeah, I was on the wrong pin. Right, 1, 2, 3. 1, 2, 3, 4, 5. That's 4. It's definitely pin 4. This is interesting. Those are all floating, and that one's definitely a signal of some kind. So let's go this one here. 7, 6, 5, 4. How many pins has this got? It's got 8 pins. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's a 16 pin device. Just not obvious because the end pins are a little bit small and just look like the same size as that. Anyway, so it's this 16 pin device. So that's 8, 7, 6, 5, 4. Yeah, it's definitely 4. So let's go to pin 5. So pin 5 is high. Let's start at 100 Hz range again. So 100 Hz low, 1K low, 10K low, 100K low, 1 meg high. Interesting. But there, see that's floating. On 100, 1K, 10K it's floating. On that range it's actually low, being pulled down. And there it's going plus 15. That's probably a fed back voltage from somewhere else. Let's go to the next pin, pin 6. Start at the bottom again, 100 Hz. So that's high on 100 Hz. High on that one. Must be feedback voltages. And on 10K it's low. Yeah. It must be voltage feedback. Right, so it's definitely low on 10K. Pin 7, it's supposed to be 100 Hz only, right? So I'm going to go downwards. Is that right? 7. Yeah, it's pin 7 there. Is on 1K. Oh, sorry, I'm getting confused there. Pin 7 is 1.7. I'll look at the wrong place in the diagram again. So pin 7, 1K, that's correct. Right, the rest all being fed back. It's interesting the other one's not being fed back. I might have to look into that just to verify that. And 100 Hz is pin 9, which is this pin over here. Oh, I'll look at the wrong chip again. It's over there just now. No, that's right. That's what happens when you look away. Okay, so that's pin 9 on the chip. It's low there, high, all the other zones. So I just need to go back and verify it's pin 4, because this is working differently. Why is pin 4 different to the rest? All the others are working correctly. Pin 4 is different. So that makes me suspicious straight away. Those aren't being pulled up. So I'm going to look at the diagram and suss it out. Okay, I've found an explanation for that difference. The pin 4 is 1 MHz output, and that just feeds straight out, whereas all the other pins are linked to the relays. So they're actually getting a pull-up voltage fed back through the coils of the relays. So that explains why there's a difference here. So those two chips are absolutely fine. Now I need to figure out what next test is I'm going to do. Right, it's going to be a little bit noisier now because I've turned the air conditioning on because it's a bit hot in here. So between all these gear running, so I'm doing voltage checks on the transistors here, the switching transistors, and just to kind of verify that they are all switching as they should be, because it's not just the relays which operate, it's also the switching transistors. So the relays are driven directly from U5, which is that chip there that drives the relays, but also provides power to these switching transistors, which are used to control something. I'm not quite sure what. Inputs to something. I'm not quite sure what they're doing actually. Anyway, they're doing something. So I have to look at that. So Q25 is one which should be off most of the time. Right, that's sorry, on most of the time. Is that right? On most of the time. So it should be on all ranges apart from 1 megahertz, which is correct. That turns off then. So measure the next one. So this one here, Q16, is only on, no, only off. I'm measuring here. I must be in the wrong place. No, that's the right one. So 100 hertz, 10 hertz, 1 kilohertz. It changes. The other zones it stays on. Now let's need to check that. It's off. It will pull up. It'll pull up when it's on. So it's only on 1 kilohertz. 10 kilohertz. Sorry, it's 10 kilohertz. Only on at 10 kilohertz. Oh, I've got this backwards. Let's check this one again. Only off at 1 megahertz. Yep, I've got that right around. It's okay. I was confusing myself here. So that's 10 kilohertz. That's on. I need to verify Q16 signal is from 10 kilohertz. Look at the diagram on the outside of the room. Yes, it is. Okay, so that's all right. Which tells me that transistor is switching okay. Measure there, which is for Q15, which is the 1 kilohertz. Yep, that's correct. Make sure it's off everywhere else. It is. And Q14 should be for the 100 hertz. Just double checking. Yep. So it should be off everywhere except 100 hertz, and it is. So those transistors are switching correctly. Okay, so these transistors here is what I was just testing. These are switching these lines, which are inputs to the phase lock circuit and the amplitude control circuit. So I verified these are working. I know these relays are switching. I haven't verified yet whether the actual, well, these are the relays up here, whether the contacts are okay. I've ticked them because it appears to be, from what I've seen from the frequency control and the levels and stuff like that, it all looked okay. Maybe apart from 100 hertz. Was it 10 hertz? No, 100 hertz range. Looked a bit low, so it might be an issue with the 100 hertz. So I'm a little suspicious about one of those. I'm going to check those. But these are inputs to these zones here. So everything else here looks okay. This is working and so on. So I've now narrowed it down to these two sections here, and possibly this 100 hertz one. So that level was lower than the rest of the zones. So I need to check those. But say someone has been playing on here, and let's just look and see which ones are the 100 hertz area. So this is C19, or C18, C17, 18 and 19, which are 17, C18, which to there. C19 is here, which are all original parts, and C51, which is here, also an original part. So those are okay, they're all original parts. So I don't see an issue with those. What had been changed was around here somewhere. I think this one here might have been changed, which is C52, but then it's an optional thing, it's not necessarily required. And C52 is used on the 1 kilohertz range, and that seemed fine, so I don't think there's an issue there with those. It's probably just factory tuning. So far so good. No faults found yet. That's, you know, it's a process of elimination, so I believe this is probably okay. So I'm looking now at these two circuits, which is I'm going to look at the amplitude control circuit first, because this one, well, actually they both link into the summing amplifier input, right, which is a signal which is missing off the other board, the oscillator board. There's no signal there, so I think it should be passing through here, because it comes in oscillator control in is over here as well, and what I'm looking for, well, I've lost it. Oscillator amplitude, oscillator amplifier out, right, which is the feedback from the oscillator amplifier. So that comes into here, splits off to both sections, and then they both feed back. So it could be either one of these units is causing a problem with the oscillator not working. So my suspicion is actually with this one here, but we'll find out, because right now phase lock, I'm changing the switch around, nothing's changing, and so that's external input and internal input. So I'd say it's probably not that one, but probably that one. We'll see. Here we go. So this is the actual circuitry here, and I'll probably do a close up on the screen when I get to more detail of it. But this is quite a complex bit here, so I may do the other section first because it looks simpler. We'll see. Here we go. Okay, so I found a slight discrepancy between the printed manual I've got here and the digital manual I've got, which is from a different source. Now the digital manual seems to be a different variant of the board. There's some slight differences I've just discovered. Now on here, I've actually drawn it on. So this is the original manual, and the other one is really crudely done, but there's extra diodes here which give a 100 Hz drive. So you've got not 100 Hz and 100 Hz drive, right? It's the opposite value. So it's an inverted output. And also there's a 1 megahertz link in there too, right? So as you can see, the original didn't have that, and I've added those in. That's what's on the electronic version of the different variant. Now if I look at this board here, these pads here are where the diodes are supposed to be installed, just here, for that variant of the board. Okay, so there's a place on the board for them, but they're not installed. Okay, so if we look at the book here, just to show a comparison, that's this area just here, right? But as you can see in this manual, they're not there. So that makes me wonder a little bit if it's something I need to be aware of, because if this is a swap out board and it's not the original one which came with the unit, because I don't know the history, it may be this version requires those parts in there. It may not use them at all. But what I'm going to do is trace through on the diagrams, goes to pin 54 on the connector here. I'm going to have to trace that through to where else it goes in the unit, it's all in the manuals, and see if that matches up as well, because it might be that I've got a mismatch in boards. Could be. Okay, so this is the motherboard interconnect diagram, so the back plane, and the oscillator board is A9 just here. Well, that's the control board, sorry. So pin 54 is here, which links to pin 53, and I come over here, so it's marked on this diagram as 100 Hz drive, and it comes over here to pin 57 and 58 of the AC to DC converter. So I'm going to have to look at that board and see what the differences are there. Okay, so what I've done here is I've pulled out the AC/DC board and I'm checking the actual physical connections on the board. So I'm looking for pins 57 and 58, so that's 54 there. So it's 56, 58, no connection. And if I look on the back of the board, which you probably can't see, if it would focus it might help a little bit, but you probably can't see in there. There's no connection on the back of the board either. So it looks like it's pretty safe. You can actually see the traces coming on the back. So 56, 58, you can see there's no trace there. There's nothing on the back of the board. So there's no connection on this board anyway. So I believe I do have compatible boards. I don't think that's a problem. I think that's okay. Okay, so back to where I was, which is looking at this phase lock circuit and the amplitude control circuit just here. All right. Now I'm going to look at the phase lock circuit first because that's a simpler one to look at. So let's scroll to the correct page. It's the second page, not the first one. Come on. Right. Now, is that going to fit on there? Yeah, it is. Right, just. So it's a fairly simple circuit, this part. Now what it gets, phase lock in over here, just there. That is from the rear panel phase lock connection, so that's an optional usage. Alright, so it goes through it says here squaring amp, so it shapes the waveform, and also got this 1000 volt range input here. So I think it only turns that on if it's in the 1000 volt range, so it's using the phase lock from the external device, which is the secondary unit which goes with it. I can't remember what it's called now, in order to get the higher voltage output range. So that's also a switching on here. So that passes through to the phase detector, which has got an oscillator zero crossing input here. I haven't looked into that part, but it's on the previous sheet apparently. So this is phase detector, goes through, positive negative supplies on here, goes to an amplifier stage. Now again, this has got compensation and tuning built into it for the various frequency ranges here. So these FETs will be switching these capacitors and resistor networks across the amplifier to tune it for each frequency range. And then it goes to this multiplier, which I haven't actually looked into yet, but it's obviously a frequency multiplier of some kind. I don't know what it does yet. I haven't read the description on it yet, but it does something, right? So, and then that goes. It's got the oscillator amplifier out as an input, so it's checking what the oscillator frequency and voltage level currently is, and it goes into this IC, which is then obviously comparing with this or counting or something. It's counting, and yeah, because it's doing square wave here, so it's not looking at voltage levels at all on the input, so it's doing square waves and stuff like that, so it's counting. And then it goes through this bit here, which is a little bit interesting, because you've got a relay here, K5, which is driven from down here, which then passes through the summing amplifier input. So that is what drives the oscillator frequency, the input frequency, right? So this is doing that pulses, which is what's driving the oscillator. So this is obviously switched in and out of circuit depending on whether it's being used or not. So the relay is controlled by K5 relay here, there it is. And we have a drive circuit here, which is from 5 volts. And that is also switching this transistor here when that's on. When the relay's on, it switches that transistor on, which switches on that FET, which does something here. don't know what it does. I think it's adding a load to it, so for stability or something. I think it was switching that FET across the output there. I think it's for stability or something. I'm quite sure. Yeah, I think that's all it does. I could be wrong. Might be interpreting that incorrectly. That's negative. That's relative to ground. So that's lower than ground. It's a negative input there because it's got reverse capacitor. Great drain source. Oh, I don't know. Anyway, we'll move on for now from that bit there. You can safely say that if this relay here is energized, oh sorry, not energized, then this is disconnected. And that drive for that relay comes from the phase lock input here on pin 31, or not phase lock. So I need to measure this input here to see if this relay is on or off. If that relay is off, this should be open and this whole circuit can be eliminated. Right, so now I'm going to test Q24 and Q33. So Q24 is the control transistor, PNP transistor, which switches the relay on and off. That's the relay just there. And Q33 is one which switches the FET somewhere where that disappears to. So let's get this powered up and we'll do some testing. Now bear in mind, I don't have any signals being fed into it right now, but I will do test the switching characteristics of these devices. So I need to figure that part out. I'm not sure what the pinout is on this particular device. So I've got 5 volts on that pin, 5 volts on that pin, minus 15 on that pin. So minus 15 will be the coil side, which means that's currently off. If I change this to external POL lock, or external phase lock rather, it goes positive. Right, I can just hear that relay clicking. Right, so that is switching just fine. If I look at Q33, which is a little trickier to measure, I think. Pins are a bit inaccessible. So nothing there. Minus 15 volts there. And minus 15 volts there. And that one there is switching. Minus 15 volts. So that is what am I looking for here? That's the collector. Yep, that's the collector turning on. That will be the base. And that's the emitter. Okay, so that's all fine. That transistor switching, that transistor switching. I can hear the relay clicking. What I need to check next is whether the relay contacts are actually working. Okay, so now I'm trying to figure out whether the K5 relay is operating correctly. So I've measured those transistors to make sure they're switching. That's fine. This Q32 right here is the FET, which should be switching as well, and that shunts across the output of this IC here. So the FET here is that pin. Yep. So when it's on, it goes to minus 15 volts. When it's off, it goes to nothing. It's just floating, right? So the FET is switching. That's fine. Now, if I measure the pin on the IC, which is pin 14, you can see that is also switching. Now, what's happening is it's shunting it to ground, right? So when it's off, it shunts it to ground. That's it. That's disabled. And when it's on, it lets it float. So anything that passes through will come through. Pin 14, when it is on, like it currently is now, is supposed to be linked to C82 negative, which is right there. Right, they look the same. When I change the switch, it doesn't change by very much. I mean, you can see the capacitor discharging, so it may be okay. Let's see what happens when it's had a chance to discharge, and I'll flick it back over again, see if it comes back up. it does. So it does appear to be switching. It does appear to be switching on that relay contact. Okay. The capacitor is just hiding it a little bit where it's discharging the capacitor. So yeah, I think that's working. So I believe I can eliminate the phase lock input as a cause of issue.